Right, in this video we're going to continue with 8.1, the law of sines. And we're going to move on to this more ambiguous case of two sides and an angle. Now, what we did in the last video and yesterday in class, we did angle, angle, side, and angle, side, angle. The common theme there were two angles given. If you're given two angles, then we know there's only one possible solution triangle. Today we got to be a little more careful. We're going to start off by being only given one angle. If this is the case, there may be zero solutions. There might be one solution, or there could be two different solution triangles that fit the prerequisites. So here it's not a lot more difficult than what we did yesterday. We just got to be a little more careful. So the ambiguous case, side-side angle. In the first two examples from the previous video, we saw that two angles and one side determine a unique triangle. There was only one possible solution. However, if two sides and one opposite angle are given, so now we have one angle and two sides, there are three possible situations. 1, no such triangle exists. 2, one such triangle exists. Or 3, two distinct triangles satisfy those given conditions. And here's how everything breaks down. If A is an acute angle and A is less than H, there's no solution. If A is equal to H, there's 1. If A is greater than or equal to B, there's 1. If A is between H and B, there might be 2. If A is obtuse and A is less than B, there's no solution. If A is obtuse and A is greater than B, there's one solution. So just memorize all that and you'll be fine. No, I'm kidding. As you start to work through these problems, they developed in a very routine manner. And as we go through, there are certain things we'll do to check. Are there more than one solution? And it's a simple test. So you'll see what's going on here in the next three examples. We're going to do one example of each. And I don't like this. They sort of spoiled the surprise. Here in example 3, we're going to work on some conditions, and we're going to see that there is only a single solution. Now let me get this picture out of the way here. And I'm going to make my own triangle. Oops, that's not a triangle. There we go. And for some reason, I always put my A at the bottom left and B at the top and C is next. You can label yours however you want. Just make sure side A is 22 and side A is across from angle A. So this side is 22. Side B is across from angle B, and that's 12. And angle A is given as 42 degrees. So we want to find all possible solutions if there are any. And the way all of these problems start is you're going to be forced to solve for one specific angle. And if we look at this here, we have an angle and the side across from it. That is going to be one of the fractions in our proportion. So we have angle A, we have side A. That tells us that 22 over the sine of 42 degrees is equal to something. Now what are we going to set it equal to? We only have one other side here, and that's side B, it's 12. So we're going to go in this direction and say 22 over the sine of 42 is equal to 12 over the sine of B, whatever angle B is, and that's what we're going to solve for. So here they're forcing us to solve for angle B. We can't do C, we don't have side C or angle C, so we cannot do that yet. We're being forced to find angle B first. So we cross multiply and set up our proportion, and we're going to see that the sine of angle B is equal to 12 times the sine of 42 divided by 22. And if we punch that in the calculator, and of course we're going to, since we're finding angle B, we're going to sine inverse the left side. And then angle B is equal to the sine inverse of this. 12 times the sine of 42 divided by 22. And we punch that into the calculator, do the old sine inverse, and we find that angle B is approximately 21.4 degrees. We've found our first angle. After we find that first angle, we're going to test for a second triangle. And it's a pretty simple test. Let me clear some room out of here. We don't need this anymore. And I should have done this from the start here. Oops. Lost my B. There could be possibly another triangle out there that has these same given conditions, but might have a different angle B. So I'm going to copy this triangle and paste it and move it over here. That's good enough, I guess. And we found angle B was 21.4. I'm going to come up to this picture. Angle B is 21.4. Is it possible that there's another triangle out there with a different angle B that has the same sine value of 21.4 degree angle? The test is easy. I'm going to take this 21.4 degree angle and I'm going to subtract it from 180. 180 minus the 21.4, calculator here. So we got our 180 degree angle, we're going to minus 21.4, and the other possible angle might be 158.6. 158.6. Now let's think about it. Angle A was given as 42 degrees. Is it possible to have an angle of 158.6 and an angle of 42 degrees in the same triangle? No. If we add those up, we're going to be close to 200 degrees. Remember, a triangle only has 180. So here, there is not going to be a second possible triangle. This is not going to work. So there is no second triangle. We can just go back and finish solving the one we were working on and be done with it. And now I can throw that away and that away. So the routine is the same. Solve for the first angle, and you're forced to solve for a specific angle. When you find that angle, check to see if there's a second possible triangle. 180 minus the angle that you found. Okay, back to this triangle. We got to find angle C and side C. Well, angle C is not bad. If we take the other two angles and subtract them from 180, we get 116.6 degrees for angle C. And I want to solve for side C. So I'm going to start my proportion by C over the sine of 116.6 is equal to. Now we have options. We could do side B and angle B. 12 divided by the sine of 21.4. If you don't like that one, we could set it equal to 22 over the sine of 42. Either one of these are going to work just fine. Let's concentrate on this one here. We do our cross multiplying, and we're going to see that C is equal to 12 times the sine of 116.6 divided by the sine of 21.4. And if we punch that into the calculator, we're going to find that C is approximately 29.4 inches. We were talking inches in this problem. Inches. So now we have all three angles, all three sides. There was only one possible solution. In example 4, again, they spoiled the surprise. They're telling us it's no solution to the SSA case. So I'm going to set myself up a nice little triangle here. And I label ABC. Side A across from angle A is 15. Side B across from angle B is 25. Angle A is 85 degrees. So we need to set up a proportion. 15 over the sine of 85 is equal to, well, we know side B, so we're sort of forced to find angle B, 25 over the sine of angle B. Cross multiply, solve for the sine of angle B. The sine of B is equal to 25 times the sine of 85 divided by 15. And of course, we are going to sine inverse at the end. So let's bring up the handy calculator here. We'll clear this out. Where's clear? There we go. And I'm going to start with the top. 85 sine. 85, and I take the sine of that. And then I multiply by 25. Times 25, that's my numerator, so I hit equals. And I divide that by 15. Divided by 15, that's my denominator, equals. So now I get this decimal. And this is now where I want to sine inverse. So I'm going to hit inverse, and there's my decimal, and I'm going to do sine inverse. Invalid input. Maybe your calculator says error. So we're getting error, or invalid, or there is no solution. There is no triangle that can have angle A as 85 degrees with the side across from it being 15 and angle B or side B being 25. It's absolutely impossible. And that's easy to see, I think, in the picture here. So come on. Here's the picture that goes with it. Remember that the information that we're given is kind of set in stone. It will not change. We were told angle A was equal to 85 degrees. This side here, B is 25. This side will not grow or shrink. Here is side A, which is 15. That was also given. That will not grow or shrink. If we imagine this vertex here is like a hinge and let side A swing back and forth, is there any chance that this side A is ever going to come down here and touch this third side of the triangle? Not a chance. There is absolutely no solution. We get that error message, write no solution, no triangle, move on to the next problem. Alright, example 5, here we are going to see the two cases that actually work. So I'll do my little triangles. And during class, I encourage the students to put a line right down the middle. And we're going to work on one side and then come back and work on the other side. And let me move this up a little bit. I need every little bit of room I can get. And again, I label my triangles ABC clockwise from bottom left. You don't have to. As long as you make sure the side across from angle A is 12. This is also 12. B is 31, 31, 31. And now angle A is 20.5 degrees. 20.5. These are the measurements that are set in stone. They will not change. So first, we're going to come over here and start to set up our proportion. It has to be 12 over the sine of 20.5 is equal to 31 over the sine of B. And we cross multiply and solve for that. You're going to find the sine of angle B is equal to 31 times the sine of 20.5 divided by 12. So we punch that in the calculator and we do sine inverse, and we figure out that angle B is equal to 64.8 degrees. 64.8 degrees. So here we've found our second angle. This is 64.8 degrees. We now test for the possible second triangle. It doesn't guarantee to be there, but we're going to test to see if it might possibly be there. Back up to the diagrams. Angle A was given. Angle B we just found was 64.8. Is it possible there's another triangle out there that when you take the sine of angle B, you'll get the same as the sine of 64.8? Well, that's just 180 minus 64.8. That might be our other angle B. And we do that subtraction, and it turns out to be 115.2. Now we need to ask ourselves, is it possible to have a triangle with a 20.5 degree angle and a 115.2 degree angle? Absolutely. So there are some degrees left for angle C here. Of course, we're going to have a different angle C here. So there are two solutions. So I'm going to come back to the left. I'm going to finish the triangle on the left first. I'm going to find angle C and side C. And then I'm going to pop over to the right triangle, and I'm going to find a different angle C. And of course, that's going to change side C. But we do have two solutions. So over here is side C. If we do 180 minus the two given angles that we already have, we're going to find this angle C is 94.7. So we can set up a proportion. C over the sine of 94.7 is equal to, now here we have options. We could do 12 over the sine of 20.5, or we could do 31 over the sine of 64.8. Let's do that one. 30 over the sine of 64.8. Cross multiply, solve for C. C is going to equal 31 times the sine of 94.7 divided by the sine of 64.8. And with a little button on the pushing on the calculator, we're going to see that C is approximately 34.2. So side C here, 34.2. Now we hop over to the second possible triangle. We already found sine B, or angle B is different. Now we're going to find a different angle C. So we do 180 minus 115.2 minus another 20.5, and we get this angle C is 44.3. So it's another proportion. Now this is C over the sine of 44.3 is exactly equal to, well, here we use the 31 and the sine of angle B. Let's go the other route. You don't have to, but 12 over the sine of 20.5. So side C is going to equal 12 times the sine of 44.3 divided by the sine of 20.5. And we do fine with a few strokes on the calculator. C is about 23.9. So here we had two distinct possibilities that did satisfy the initial conditions. And let's see how this works here. Clear. My first angle up top, these are going to be slightly different due to rounding, but here we have 64.8 degree angle, and when we take the sine of that, I'll scribble it in there real quick, it's 0.9048. 0.9048 when we took the sine of this angle B. Now let's do the sine of the other angle B. 115.2. 115.2. And we take the sine of that and get 0.9048. 0.9048. That's why we have to look for two solutions. There are two different angle B's that give us the same sine value. You know, on the unit circle, do this, oops. If we were thinking about this from the perspective of the unit circle, you know, here's our unit circle. If we find a sine value, remember sine is a y value. If we find a sine value here of something, you know, we would look straight across the unit circle to this same height. These have the same height, or the same y value. Whatever this y value is, this y value is, and y values are sine values. That's why we might have two distinct solutions. And let's see here, we do have a picture that goes with this. The given information was set in stone. Angle A was 20.5. That's the same on both triangles. This side B is 31. This side B is 31. That's not going to change. Side A is 12. That is not going to change. But again, imagine this is a hinge. And this side length 12 can swing over and hit again right here and stop. That's our second triangle, as we see right here. We had a 64.8 degree angle in our first triangle for B. We have a 115.2 in this triangle for angle B. And of course, when angle B changes, that's going to change angle C. Here angle C was obtuse. Here angle C was acute. And of course, that did change the length of side C. For the huddle, number 25 is one triangle. Number 26 is a different triangle. You know, analyze them separately. Do the work, see if there is a second possible triangle. If there is, solve that triangle too. You might have one solution, you might have no solutions. So pause the video, try number 25 and 26, and then start it back up and see how you did. So 25. Angle A is 110. Side A is 125. Side B is 100. And it looks like they're forcing us to solve again for angle B. So we have an angle on the side across. That is going to be 110 divided, what am I thinking? 125 divided by the sine of 110 is equal to our other diagonal, where we have the side 100, but we're missing angle B. So that's 100 over the sine of B. So we solve that for B. Sine of angle B is equal to 100 times the sine of 110 degrees divided by 125. And then, of course, we sine inverse to find B. And if we do the button pushing correctly, angle B is about 48.74 degrees. So let's see, could there be another triangle with a different angle B? So this is 48.74. Let's think, is there a second triangle? We don't know. So we're going to do 180 minus the angle that we just found, 48.74. 180 minus 48.74 is 131. So if angle B up here was 131 and this angle A was 110, does that violate the rules of geometry for a triangle? You bet. That's over 200 degrees. Triangles are limited to 180 exactly. So there is no second triangle. We just have to finish the one we started, and we're done with number 25. So we now have enough information to find angle C. Angle C is 180 minus 110 minus 48.74, and that tells us it is 21.26. Side C is across from it. So side C divided by the sine of 21.26 is equal to, let's do the A, 125 over the sine of 110. Cross multiply, C is equal to 125 times the sine of 21.26, all divided by the sine of 110. A few strokes on the calculator, and we're going to find C is approximately 48.2. 48.2. And the triangle is solved. All angles, all sides accounted for. Ooh, I guess, yeah, we'll do that. Angle A, this is for number 26. Angle A is the same 110. Side A is the same 125. But now side B has changed. Side B has grown to 200. Does that mess anything up? Well, let's see. Here's where we start. 125 over the sine 110. And we set that equal to 200 over the sine of B. And with a little cross multiplication, we're going to see the sine of B is equal to 200 times the sine of 110 divided by 125. And let's see what that looks like. Clear. So we have 110, and we're taking the sine of that. We're multiplying that by 200 times 200 equals, that's our numerator. Divide that by the denominator, 125, hit equals, there is our decimal, and now we want to do sine inverse. So inverse sine, invalid input. So we get, for angle B, error. Or invalid input, there is no solution. There is no triangle. And we come back to here, look at that decimal. If we back up a step, oops, I guess you can't do that. We had the sine of B was equal to 1.5035. 1.5035. Remember, for the sine function, no matter what you plug in for what you're taking the sine of, what comes out is always a number between 1 and negative 1. So x is always between 1 and negative 1 or equal to 1 and negative 1. This is outside that range. 1.5 is outside of 1 to negative 1. So we get that error message. There is no solution. For the homework, page 604, 4 problems, 19, 20, 21, 22. 2 of them are odd, 2 of them are even. Check the odd ones in the back. If there are 2 solutions, solve for both of those triangles. Remember, solve for your first angle. Take that angle, subtract it from 180, and see if that creates another triangle that makes sense. If you go over the 180 degree limit for a triangle, it doesn't make sense, and there's only one solution.